Hello everyone, this is our third class for pre-calculus. Today we are going to talk about trigonometric functions. So the first important point is the conversion between radian and degree. They are both measurement of angle. To convert radian to degree, multiply by 180 degrees over pi radians. To convert degrees to radians, multiply by pi radians over 180 degrees. And the second part is trigonometric functions. For the right triangle ABC, these are the sides ABC, and this is the angle theta. So sine theta is A over B. Cosine theta is C over B. Tangent theta is A over C. And cosecant theta is B over A. Secant theta is B over C. And cotangent theta is C over A. And next, let's talk about standard position. We first draw a coordinate system. The vertex of the standard position is the origin, and its initial side lies on the positive x-axis. The terminal side can lie on any place, such as here. And this is the standard position. This angle is a positive angle, while this is a negative. These two angles are the coterminal angle of each other. For example, one of the coterminal angle of 30 degrees is minus 330 degrees. Next, to solve trig functions, we can use drawing a coordinate system. For example, to solve the 6 trigonometric functions of 315 degrees, we can first draw this angle in the coordinate system. This is 315 degrees. So this angle is minus 45 degrees. The sides of 45 degrees angle are easy to calculate. These sides are 1. This is minus 1. And this is the square root of 2. Because minus 45 degrees is equal to 315 degrees. So sine 315 degrees is minus 1 over the square root of 2. Cosine is 1 over the square root of 2. Tangent is minus 1 over 1, which is minus 1. And the cosecant, secant, and cotangent is the opposite of these three. Next part is the graph of sine and cosine. Fx equals to sine x. The graph is like This is the origin. The range is from -1 to 1. Fx equals to cosine x. The graph is like this. The range is the same as sine. A function is a sinusoid if it can be written in the form fx equals to a times sine bx plus c plus d, where a, b, c, d are constant and neither a nor b is zero. The amplitude of the sinusoid is the absolute value of a. The period of the sinusoid is r pi over the absolute value of d. The frequency is the absolute value of d over 2 pi. Next part is the inverse function. The inverse functions of sine and cosine are based on restrict sine and cosine functions. In the restrict sine, the domain is from minus pi over 2 to positive pi over 2. The range is from -1 to 1. So the graph is like, so in the inverse of sine, which is arcsine, the domain is the range of restrict sine, which is -1 to 1. The range is the domain of the restrict sine, which is minus pi over 2 to positive pi over 2. So the graph is like, in the restrict cosine, the domain is from 0 to pi. The range is from -1 to 1. The graph is like this. The arc cosine is the inverse of restrict cosine. The domain and the range are opposite. The graph is like, the important thing is that the input of restrict sine and cosine is angle, while the output is trigonometric ratio. So as for the arcsine and arccosine, the input is ratio, output is angle. To solve inverse functions, for example, arcsine sine pi over 9 is pi over 9. Okay, this is all for today. Thank you.